Okay, this is homework practice 2.4. This is the Spurs, their height, and the number of rebounds they got. We want to find the R value, the correlation between them. Okay, so first thing I did was I put these into Desmos and found their mean and standard deviation. And same thing for your Y's and found the mean and the standard deviation. If you don't know how to do that, go watch the instructional video for the day. Okay, next we have to find the z-score for our x's. So for the x here, for this x, the z-score is the score minus the mean divided by the standard deviation. Okay, so 83 minus 79.3 divided by 3.15 gives you a z-score of 1.17. Okay, and then we have to find the z-score for the y value as well. So for the z for the y, it would be the score is 211 minus the mean of 115.1 divided by the standard deviation of 57.84. So 211 minus 115.1 and divide that by 57.84 gives you a z-score of 1.66. Okay, you can round stuff here. I'll do one more and then you can do the rest. Okay, my z would equal that person's score minus the mean divided by the standard deviation. Okay, and you got negative 0.10. Okay, and then this z score, 155 minus the mean divided by the standard deviation. Gives you a z-score of 0.69. Okay, I'm going to find the rest and I'll unpause it then. Okay, so I found all of them here. If you want to pause it and check them, you can. So the next thing we need to do is we need to take this z-score times this z-score. So the z-score for the x and multiply it by the z-score for the y. I'm going to pause it and multiply those. Okay, so these multiplied together give you this. Okay. Now, if you round it differently and have these numbers just a little bit different, that's totally fine. Okay. Now what we need to do is we need to add all these up together. Okay, so I'll add those up here yet. Okay, I got a sum of 5.0046. Okay, your number should be somewhere around there. And lastly, divide by n minus 1. So there are 1, 2, 3, 4, 5, 6, 7. Okay. 7 minus 1 is 6. If I take that and divide it by 6, I get an R that is about 0.8341. Okay? If you go on Desmos and do it, you'd probably get something that's a little bit different than this, just because all these numbers, I rounded them as I was writing them down. Okay? But it should be somewhere around there. Okay? Number 2, you want to actually find it on Desmos, so I'm going to go on Desmos and find that in the video. I'll show you that.
Okay, so here I am with question number 2. It's the distance from Philadelphia and also the cheapest fare. Okay, so here we have the distance and how much a ticket costs on the airplane. So presumably you'd think the farther you go, the more expensive it gets, right? Okay, so how closely is this correlated? So to find that on Desmos, you have to use your equation, y1 tilde m x1 plus b. Okay, so there's your slope and y-intercept. But where we're interested in the correlation, which is 0.8907.
Okay, for question number 3, in a famous study published in 1948, engineer George Washington Pierce investigated the relationship between air temperature and the rate at which crickets chirp. So here you can see that. So the warmer it is, the faster their chirps are, the more they chirp. Okay, and it gave a correlation of 0.835. Okay, so part A. What would happen to the correlation to this 0.835 if it was plotted, if you switch the two? If this was plotted on the y and this was plotted on the x. Okay, well, the graph would look a little different, okay, but the actual correlation would stay the same. So R would still be 0.835, the same. Okay, that won't change it. Part B, what would happen to the correlation if the air temperature measured in Celsius versus Fahrenheit? So we have Fahrenheit. What if we change this to Celsius? Okay, well, the graph would look a little different. We might have a different slope to it and stuff, but our correlation will stay the same. Okay, in part C, somebody claims that the correlation is 0.835 chirps per minute. Okay, what's wrong with that? Okay, it's not correct because that R has no chirps per minute or any other unit. It's just 0.835, no other units. Okay, so number 4, looking at airplane crashes. So should travelers avoid flying airlines that have crashed in the past? So Nate Silver asked this question in 2014 and found some results here on the scatter plot. They took 56 different airlines in 2 different periods and plotted them. Okay, and here's the plot here. Does the highlighted point, this point right here in red, which is Aeroflot, how does that affect the correlation? Okay, so in the 2 years, okay, so the correlation, is, the line of best fit would be about here, right? So this point is outside of our line of best fit, pretty far away from our line of best fit. So it will, if it was really close to the line of best fit, it would increase our R, it would make it closer to 1. But since it's so far away and outside of our line of best fit, it will decrease the R and make it closer to 0. Okay, so number 5, looking at this data here, and basically it says, how does the point highlighted in red, which is Kenya Airways, how does that affect the correlation? Okay, so once again, our line of best fit is probably around this area right here. Is that strong? Does that make our line stronger? Is it grouped around all of our other points? No. Does it make it weaker? Yes, it does. Okay, so this will make the correlation, our R value, weaker, closer to 0. Okay, so here we have the weight of a mixer in your kitchen and the price of it. So generally, the more that it weighs, the more it costs. Okay, this point right here, how does this affect the correlation? Okay, so without that there, our correlation would probably be about right here, which that point is right on that line of best fit, right? So having that point there makes it stronger. We would have a certain correlation there. This correlation would be closer to 1. It would be a stronger correlation because it's right on or very close to that line of best fit. Okay, for 7a, so there's an error in each of these. We have to identify those. It says there is a high correlation between the gender of American workers and their income. Okay. Since these are, gender is categorical, we would not say that this is in a correlation, but we could say there is an association with them. So because it's a category, we would not use the word correlation. We would say there's an association between the 2 variables. Okay, thinking back to our stacked plots the other day. And the last one here, it says we found a high correlation of R of 1.09 between SAT scores and GPA. Okay, so once again, you could make a scatter plot with scores and GPA, but you're never going to have an R greater than 1. So 1.09 is the error there.